Do 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 do. So let's do just like we would if we were in class. Let's start with a warm-up here. So you pause the video, try these two out. So draw a Bohr-Rutherford diagram of an oxygen atom, and then draw a Bohr diagram of a calcium ion. Just want to remind you, atom and ion, so they're going to look different. So pause the video, try those, and then I'll reveal the answers. Okay, let's see how you did. So here's the answers. So number 1 was draw a Bohr-Rutherford diagram of an oxygen atom. Remember, Bohr-Rutherford, 2 words, so 2 things go in the nucleus, the number of protons, number of neutrons, and then if it's an oxygen atom, it should also have 8 electrons arranged, 2 in the first orbit, and then 6 in the second, in this order, 2, 2, 1, 1. Draw a Bohr diagram of a calcium ion, so that's after it has gained or lost electrons. Calcium is a positive ion. It loses 2 electrons. Remember, losing negatives makes you positive. So it's Ca2+, and we would have 2 in the first orbit, 8 in the second, 8 in the third, for a total of 18. Hopefully you got those 2. If you didn't, go back and review how to draw Bohr-Rutherford and Bohr diagrams of atoms and ions. Those are going to be important for today's lesson. That being said, let's jump right into today's lesson. We are going to talk about compounds. So now putting different atoms together to make something new. So a compound is a substance that's made by combining 2 or more different elements together. We're just going to look at 2 together in grade 9. So as an example, here we have Na, sodium, and Cl, chlorine. Sodium is a silver metal. Chlorine is a poisonous gas. You put them together, and what do you get? You get this, which, if you know some chemistry, is NaCl, or table salt, believe it or not. So you put 2 things that can be pretty dangerous together, gives you something totally new with different properties. This is a compound, and it's going to have different properties than either of the elements that it came from. So let's figure out, how do we actually come up with some of these compounds? We're going to look at diagrams to do this. So we can use Bohr diagrams to learn how elements move electrons to become compounds. Now, one thing, I'm not sure whether I put it in the last video or not, is we're going to be talking about ions again, so positive and negative ions. So I just wanted to introduce some new terminology. A positive ion, or positive ions, are called cations. And the way I remember that is cats have paws, positive cation. So that means negative ions are not called dog ions. They're actually called anions. And we'll talk a little bit more about how words are formed, but the prefix "an" actually means negative here. Okay, so let's look at what happens when you combine lithium and fluorine. So we're going to draw Bohr diagrams for these, and we're going to see what these look like. So I give you some pretty easy ones to begin with. So we're just drawing Bohr diagrams. So lithium, you put the element symbol in the first. It is atomic number 3, so it should have 3 electrons. 2 in the first orbit, and 1 in the second orbit. Fluorine, on the other hand, let's draw it over here, is atomic number 9, so it has 9 electrons. 2 in the first orbit, leaving us 7 in the second orbit. Remember, we go clockwise. 1, 2, 3, 4, 5, 6, 7. All right. What does lithium want to do to become stable? Well, it wants to lose 1 electron. What does fluorine want to do to become stable? It wants to gain 1 electron. So guess what? Lithium and fluorine are a match made in heaven, because lithium is going to lose this electron, but it's not just going to lose it to anywhere. It's actually going to give it to fluorine, which is looking for an extra one. So now what are we going to have? We're going to have a lithium ion, a cation, which is stable. We're going to have a fluorine anion, which is also stable. So we've actually just created a compound using lithium and fluorine. So I've got 2 questions here. Will it make a compound? Yes, we just saw how it would. We take 1 lithium, 1 fluorine, we give 1 electron from lithium to fluorine, and away we go. So what is the formula? So the formula is LiF. What we do is we write the cation, or the one that's giving away the electrons, first, and we write the anion, or the negative ion, or the one that's receiving electrons, second. So we put LiF. So if you wrote FLi, you would get a big X. This is not correct. Okay, so the cation comes first, anion comes second. Let's try another example. What about sodium and oxygen? So we're going to do the same thing here. So sodium's atomic number 11, so it has 11 electrons. 2 in the first orbit, 8 in the second orbit. I'm going to cheat here a little bit and know that it's filled, so I'm going to pair them up, even though I should do one around and then go around a second time. And that gives us a total of 10, so we need one more. Here's my 11th one. What about oxygen? Oxygen's number 8, so it needs 8 electrons. There's my nucleus, so 2 in the first orbit. And we can have 6 in the second orbit. Hey, this was one that we did for the warm-up there. Hopefully you tried it. Okay, so there's our 8 electrons for oxygen. So what's going to happen now? Well, what does sodium want to do to become stable? It wants to lose this 1 valence electron. What does oxygen want to do? It wants to gain 2 valence electrons. So it's not quite as easy as the last one. So you may have guessed sodium is going to give away that 1 valence electron. So here we go. Sodium's happy now. Sodium is stable. What about oxygen, though? Oxygen's still looking for 1 more. So how can it gain 1 more when sodium doesn't want to give away anymore? Well, what we're actually going to do is we're going to have a second sodium ion. So let's see if I can do this real quick. Oh, look at that. If we were in class, you guys would hate me because I would do that right there. You're probably hating me a little bit right now because you have to draw it still. So we've got our second sodium atom. It's going to give away its 1 valence electron to oxygen. And all of a sudden, oxygen is now stable. These 2 sodium are both stable. So everything's stable. It's all good. Will this make a compound? Yes, it will. What is the formula? So remember on the last slide I told you the one giving away the electrons, or the cation, has to come first. Same idea here. So that would be sodium. And the anion, or the one receiving, comes second. So that's the O for oxygen. Now the difference between this one and the last one is now we have 2 sodium. So we have to represent that somehow in the formula. And we do that with a little subscript right here. This 2 is telling me that there's 2 sodium. It's only applying to whatever it's right beside. So this tells me 2 sodium. There's only 1 oxygen. I could write a little 1 right here as a subscript, but we are efficient, not lazy, remember? So we are not going to put a 1 here. We're just going to leave it blank, and we're going to assume that if we don't have something written there, it is actually a little 1. All right, example 3, aluminum and chlorine. So we keep getting a little bit more tricky each time. So aluminum is number 13, so we're going to have 13 valence electrons. Sorry, 13 electrons, I should say. So we'll have 2 in the first, 8 in the second, and 3 in the third. So 1, 2. I know there's 8 in the second one. That's totally filled. So 2, 2, 2, and 2, and then 3 in the third. So 1, 2, 3. All right, chlorine is number 17. Wow, we're drawing big ones here. So 17 electrons gives me 2 in the first orbit. Remember using our rule 288. I've been using that all along. So 8 in the second gives me a total of 10 so far. And we need 17, so we're going to draw 1 more here. Whew, some pretty bad circle drawing. 1, 2, 3, 4, 5, 6, 7. All right. What do we want to do here? Aluminum wants to lose these 3 valence electrons to become stable. Chlorine only wants to gain 1. So what's going to happen? Well, aluminum has 1 to start off with to give away. So here we go. Chlorine is now stable. This is similar to the last question, though. We still have one that is not stable. The aluminum in this case, it has 2 more that it needs to give away. So it can't give any more away to this chlorine. Whoops. So you can probably guess what's going to happen. We're going to need more chlorine. So let's see if we can give ourselves some more chlorine. You're welcome for doing that again. And we'll need another one of those as well. So let's bring it over here. So now we've got aluminum giving this chlorine one and aluminum giving this chlorine one. Now aluminum is stable. This chlorine, and this chlorine are all stable. So again, we've managed to do this. We've had to draw more than we have before, but that's okay. So will this make a compound? Yes. What is the formula? Again, we put the cation or the positive ion or the one losing electrons first, so Al for aluminum. We put the anion or the one gaining or the negative electron second, or the negative ion, I should say, second. And we have 3 chlorine, so we have to represent that as a little number down at the bottom, a subscript. We're going to write it next to the chlorine to tell us that there's 3 chlorine. This is only applying to chlorine. It doesn't apply to aluminum. Again, we could put a little 1 here to say there's 1 aluminum, but why bother? All right, what about beryllium and nitrogen? So this one is the trickiest you're going to get. Beryllium is number 4, so it's got 4 valence electrons. So 1, 2 in the first, 1, 2 in the second, and nitrogen is number 7, so we will have 2 in the first and 5 in the second orbit. 1, 2, 3, 4, 5. All right. What's got to happen here? Beryllium to become stable wants to lose 2. Nitrogen to become stable wants to gain 3. So let's start exchanging electrons here. So there we go. Beryllium gave 1 away. Beryllium's going to give a second one away. So beryllium is now stable. What's the problem with nitrogen? Nitrogen still needs another one. So where is it going to get that from? It's going to get it from another beryllium. So let's see. We've got a second beryllium. So now beryllium has an extra electron to give nitrogen. We're all good, right? Wrong. The second beryllium we drew now has another electron to give away. So what's it going to do? It's going to give it away to another nitrogen. So let's keep going. So we give this one away. Whoops, that's supposed to be on there. So we're good, right? Beryllium's both stable, good. Nitrogen stable, oh crap. This nitrogen still is not stable. It needs 2 more valence electrons. Where's it going to get those from? You guessed it, another beryllium. This, in fact, is the hardest that you're going to get, where you're going to end up having 3 of one of them and 2 of the other. Now let's take a look. All these beryllium are stable. They've all lost 2 valence electrons. All 2 of these nitrogens are stable. They've both gained 3 electrons. So we are done. This is the biggest thing we're going to have to draw. So will this make a compound? Yes. What is the formula? Again, cation first, so Be for beryllium. Anion second, N for nitrogen. And don't forget our subscripts telling us how many we have. So we have 3 beryllium and we have 2 nitrogen. So Be3, N2. Last example here. What about fluorine and chlorine? So we've actually drawn both these before. So fluorine is number 9. So 9 valence electrons here. 1, 2, and then 7. 1, 2, 3, 4, 5, 6, 7. Chlorine is 17. Why couldn't I have drawn smaller ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can't believe I'm going to put this on the internet, with this terrible writing. 11, 12, 13, 14, 15, 16, 17. So now someone's going to forever know that I can't draw circles using a tablet. All right, what's fluorine want to do to become stable? It wants to gain 1 electron. What does chlorine want to do to become stable? It also wants to gain 1 electron. Uh-oh. They both want to gain. Nobody wants to lose anything. So is this going to form a compound? No. Not in grade 9. We'll learn in grade 10 that it can, but for grade 9, we're just going to say, no, it will not make a compound. So what's the formula? There is no formula. Not applicable.